This is AQA Statistics, Continuous Random Variables 4. This video is about the cumulative distribution function for simple PDFs. Please pause a moment to read the definitions on the slide. We can define the cumulative distribution function for a continuous random variable with PDF given by f of x. Now, the cumulative distribution function can be abbreviated to CDF. The capital letter F is used to represent the CDF, and this is a probability that the random variable x lies up to this variable value for x. Sometimes we can find the CDF by geometric considerations, but in general the CDF is found by integration of the PDF. We need to integrate all the way along from negative infinity up to our variable value of x. Please pause for a moment to read the example. Consider the shape of the PDF and how you might go about answering the questions. Before answering part A, let's have a look at the sketch graph of the PDF. And we can see we have this straight line function between t equals 0 and t equals 10. Now, if we're looking for the cumulative probability up to a variable value t, then that will be given by the area under the graph. So this area here is going to represent the CDF up to the variable value t. The area of the triangle we can work out using the usual formula. Here we see the width of the triangle is t, and the height of the triangle at the right hand side here is going to be f of t, which is 1/50th of t. So here we are, a half of t times f of t gives us a half of t times 1/50th of t. Simplifying that, our CDF, our cumulative distribution function, is t squared over 100. Here we have the full definition of the CDF, and there are three elements to this. We have the part where t is less than 0, where there is 0 probability, so f of t is equal to 0 in this range. In the non-zero part of the PDF, between t is between 0 and 10, then we have this expression here that we've calculated, and then when t is greater than 10, then the cumulative probability will be 1 for all values, because there is no probability that the random variable takes a value greater than 10. Now, part B of the question is to work out the probability that t is less than 8, and we need to remember that that probability will be given by the CDF of 8. So, substituting in then, 8 squared over 100 gives us 0.64 for the probability that the random variable t takes a value less than 8. We can find the median length of a phone call by making use of the CDF. This statement is now equivalent to saying the probability that the random variable t is less than Q2 is equal to 0.5. As required, if we substitute in the CDF that we've derived previously in the question, we now have Q2 squared over 100 equals 0.5. And if we rearrange and take the square root, we finish up with the median value for a length of a phone call is 7.1 minutes. Please pause the video to read through the example and consider how you would go about answering questions A and B. In order to set about finding the CDF within this range for x lies between 1 and 4, we would need to start by expanding the brackets of this cubic expression here. So here are the brackets expanded, And what we now need to do is to integrate from the lower limit here 1, the first value for which the PDF becomes non-zero, and we need to integrate up to this variable value x. And here we see we've integrated term by term as usual, and then we've got to evaluate this integral at the two limits. We now need to carry on by substituting the two limits into the expression for the CDF. And we see here the whole expression remaining as x, and then over here we've got the expression where 1 has been substituted in for x. If we simplify all of this and bring the terms together, then we finish up with this quartic expression here. Here is the full definition of the CDF. We see that the CDF is 0 when x lies in the range less than 1. For values of x between 1 and 4, then we've got this quartic expression here to represent the PDF. And then when x is greater than 4, since there's no probability, then, or the random variable can be greater than 4, then the CDF for x is greater than 4 is 1. It's always a good idea, if you can, to do a sketch graph of the PDF that you've derived. And here we see for values of t less than 1, then the CDF is 0. Values of t greater than 4, the CDF is 1. The quartic expression moves smoothly from x equals 1 to x equals 4. In part B, we're required to show that the median time for completing the half marathon is 2.2 hours to 1 decimal place. We need to notice here we have got a quartic expression for the CDF, so it won't be possible to set f of the median equal to 0.5. That's going to be an equation that's too difficult to solve, so we must use a numerical method. Now, the method we can use here, if we take values that are just bracketing either side of 2.2, 2.15 and 2.25, if we then have a value here which is less than 0.5 and a value here which is greater than 0.5, then we can infer that the median value must lie between those two. Now these are given to 2 decimal places, and any number which lies in between those two values, when we round to 1 decimal place, that will give us 2.2. That completes this video. The next video is on the cumulative distribution function for piecewise PDFs.